Okay, I have here some more trig equations. We're going to solve these. And one technique that we've talked about in the past, which you may prefer, you may not, is U-substitution. So in this one up top, I'm going to notice that everything is in terms of cosine. What if I just changed everything that says cosine omega to the letter U? Well, now we get the following. We get negative 2u squared equals 2 minus 5u. And that should strike you guys as familiar. We've done equations like this before, which involve factoring and getting one side equal to 0. So if you rearrange this, I'm going to add 2u squared to each side. We get 2u squared minus 5u plus 2. And that looks like I can factor it. Hopefully pretty easily. We've had some practice at factoring before. So I'm going to have 2u and 1u. If you want to use the big X, that is great. Go ahead with that. I'm just going to guess. And let's see if this works. I have 2u squared right there, so that's nice. And let's see, I have negative 1u and negative 2u times 2, so that's negative. That adds up to negative 5u, that's great. And then negative 1 times negative 2, that's positive 2. So it looks like I have factored this correctly, and I'm just about ready to solve it. I get two solutions. Remember, we get a solution for each parentheses here. One of my solutions is u equals 2. One of my solutions is u equals 1/2. And remember, we're not solving for u, we're actually solving for cosine. So that means cosine of omega equals 2 and 1/2. Well, where on the unit circle is this going to be true? Here's my sloppy unit circle right here. Okay, 2, 2, how about that? Where is that on here? If you remember, cosine always has to be something between negative 1 and 1. This is not allowed. This is a big old DNE for that cosine equals 2 part. But cosine 1/2, that looks fine. That's going to be values here. Remember, cosine is the x coordinate. So I'm looking at angles that are kind of steep here. This is an angle of pi over 3 and an angle of 5 pi over 3. Okay, so that'll be my solution for omega. Pi over 3 and 5 pi over 3. So I want you to watch out for results that you get which are not actually possible. Okay, the big one here being this whole u equals 2. It's like an extraneous solution. So next one, let's try this equation. 3 tangents equals 4 sine squared tangents. And you'll notice right away, I've got tangents and I've got sines in here. So maybe u substitution isn't really what we want to go for here, unless you want to do maybe a uv substitution, right? Maybe u equals sine and v equals tangent. But at that point, I don't think we're really making things easier for ourselves. I'm just going to go right into factoring. And I'm going to subtract 3 tangent from each side. Okay, that's the first step I'm going to do here. So I get 0 equals 4 sine squared omega times tangent omega minus 3 tangent omega. And after you get 0 on one side, then we want to factor. And I see a GCF. Greatest common factors are the first thing you should look for. Okay, so GCF of tangent omega. So what's left behind after we factor out the tangent? Well, 4 sine squared omega minus 3. Okay, now that's something I can solve. Here are my two solutions. For this one right here, I get tangent omega equals 0. For this one over here, I get 4 sine squared omega minus 3 equals 0, which needs some more work, right? I add 3 to each side, and that becomes 4 sine squared equals 3. Sine squared equals 3/4. And now we need to square root each side to say sine omega equals square root of 3 divided by 2. Okay, that's the square root of 3/4. And there's one more thing to remember here. Everyone always forgets this part. When you square root something, when you are the one creating the square root, it has to be plus or minus. Okay? When you square root 9, you get plus and minus 3. When you square root 3/4, you get plus or minus radical 3 over 2. Now, we need to think, oh, here's a unit circle. I'll just use this one. So what are my two things here? I've got tangent equals 0. Okay, let's use a color that's going to show up nicely. Hot pink. Tangent equals 0 is right there and right here. So that gives me two solutions, 0 and pi. Now sine equals plus or minus radical 3 over 2. We're looking for all the y coordinates that are plus or minus radical 3 over 2. So here's positive radical 3 over 2, these ones up here, and here's the negatives, n and l down here. So these are all my solutions. There's quite a few of them. Looks like I've got 0 and pi from tangent, and from the sine portion of the equation, we have pi over 3, 2 pi over 3. I'm just going counterclockwise around the unit circle. And then we have 4 pi over 3 and 5 pi over 3. Quite a few solutions to this equation. But that is kind of the nature of things when you have sines and tangents all mixed together, as you will in quite a few of these equations.